For question number 13, one of the conditions at which quantum mechanics simplifies to classical mechanics is when the quantum number n approaches infinity. What is the probability density for the particle in a box in this limit? Does this agree with the classical prediction? So let's start by drawing the three lowest energy wave functions for a particle in a box. So let's start off with n equals 1. Something like this. Goes from 0 to L. Okay, for n equals 2, we'd see something like this. Also from 0 to L. So the x-axis represents the position. For n equals 3, we would see something like this. Now, if we want to find the probability density at that energy level, we would just square all the functions. So the shape of the first function will look the same. However, for the second one, the shape would look different because you had negative values here. Now when we square it, the negative values will become positive. So it will look something like this, with two peaks. Okay. And then for the third one, again, the negative values become positive when they're squared. So you have 3 peaks. So as you can see, as n increases, so this is 1, 2, 3, as n increases, the peaks and the troughs get closer and closer together. Therefore, you can imagine at n equals infinity, the peaks are really, really, really close. So you have to remember what this curve means. So the x-axis represents the position in the box. The function, it represents the probability of finding that particle at that particular position. So you can imagine when n is infinity and there's so many peaks so close together that the probability you would find a particle at any position would be the same as any other position in the box. So if you imagine if these peaks are really close together, they would have the particle would have the same probability of being in the same position. Therefore, when n approaches infinity, quantum mechanics simplifies to classical mechanics, because now in classical mechanics we predict that if a particle is bouncing around in a box, the probability of finding the particle at any position in the box is the same as any other position.